Today I'm going to present my presentation on assessment 2 on real world analytics. So starting with the introduction and data distribution. So in this presentation I'm going to demonstrate how we can apply weighted regression functions to determine wine quality based on characteristics such as citric acid, chlorides, total sulfur dioxide, pH, alcohol quality, which are donated with the variables x1, x2, x3, x4 and x5. So starting with these scatter plots, in this scatter plots, I have compared the x1 variables with the y, which is quality. So starting with citric acid and quality. So the aim for using scatter plots is to understand the relationship between citric acid, which is x1, and quality, which is wine. So we can expect that the quality of wine remains stable or an average when the citric acid is between 0.0 to 0.4. So we can also say that if the citric acid is increased or is between 0.4 to 0.6, the quality of wine also becomes higher at 7. So there is a positive relation. Now moving forward to chlorides versus quality, it is clearly evident that the quality of wine decreases when the amount of chlorides is increased. So this is an approximate negative trend. Moving further to the total sulfur dioxide, in this case there is much not data recorded between 200 to 300, is it evident, and it is also seen that the quality of wine is finest when the total sulfur dioxide is low. Hence there is a negative correlation. And here is the scatter plot for pH. It is observed that the quality of wine remains best when the pH level is between 3.2 to 3.4, and it is also noted that very less data is presented between 3.8 to 4.0. Moving to the last, alcohol, it is clear that the quality of wine remains highest when the alcohol is highest, and so hence there is a positive relation between the two. Moving towards the histogram, the first histogram is of citric acid. It is clear with the histogram that the citric acid data is skewed to the right, where the minimum value is 0.0 and maximum is 0.79. Moving forward to the chlorides, in the following graph of chlorides, it is shown that it is also rightly skewed. Moving forward to the total sulfur dioxide, the graph shows the maximum value of 289, minimum value of 6, median of 42 and mean of 48.9. Moving forward to pH, here the graph indicates the minimum value of 2.89 and maximum of 3.4. Moving towards the alcohol, the distribution of alcohol data shows that the maximum is 14 and minimum is 8.0, and it is also seen that the distribution is also skewed to the right. In the quality, so although the quality of wine should be between 0 to 10, but in the selected sample, which is of 400 sets, the data in data set, the lowest is 3 and the highest is 8. So talking about the transformation that has been applied is for the x1, which is citric acid, I have used scaling technique of transformation for the transformation in x1, and the values produced after scaling range from between 0 to 1. In chlorides, I've used linear scaling approach, and it is also a positive skewed distribution, and the value is ranging in between 0 to 1. In the total sulfur dioxide, I have used log and minimum max functions. In the alcohol, to acquire data in appropriate 0 to 1 interval, I have used log transformation and minimum max scaling. When it comes to the quality of data is clearly visible that data is already distributed normally, hence I haven't made any changes with the quality. So after applying the transformations and applying the weight aggregation functions, it is clear that the RMSE in the weighted arithmetic mean is the lowest, and also the error is lowest, whereas for the ordered weight average, the RMSE is highest and average absolute error is also highest. When it comes to correlation functions, it is clear that the alcohol has the highest as well as the strongest relation between the quality of wine, which means that the quality of wine will increase as the amount of alcohol. When it comes to weight measures, here I have defined what does RMSE mean: average absolute error mean, Persman correlation coefficient, and Spearman correlation coefficient. By looking at the previous weighted aggregation functions, it is clear that the weighted arithmetic mean is the best model for prediction based on the affirmation criteria, since it has the lowest RMSE, average absolute error, as well as the highest Perman and Pearson correlation coefficients. And also talking about the best fitting model, the RMSE of the weighted arithmetic mean stayed at the lowest, which is at 0.706, and lowest absolute error with 0.538, whereas ordered weighted average function has the highest. So to predict the wine quality, and I applied the following functions, and it is clear the quality of predictions came out to be 8, which appears to be appropriate. And when it comes to me, I'm satisfied with how the prediction model performed when compared to the raw data set for similar inputs. So to determine the best conditions for quality of wine, it majorly depends on the alcohol, as it has the highest correlation coefficient. So to get the best quality of wine, the following factors should be between these limits. The citric acid should be between 0.4 to 0.6, chloride 0.0 to 0.1, and same with the sulfur dioxide and alcohol. So discussing about the limitation and implications of the weighted arithmetic mean that I have used for the prediction. So the first limitation is we limited ourselves to only 4 variables column in this task, which limits the fitting model capability to produce improved predictions. The possibility of predicting correct outcomes increases as the number of factor increases, which is correct. And the second limitation is it is also seen that the data sheet here, which is provided, is very supervised, and it only has 400 rows. Hence it is completely possible to have accurate results. However, if the data set is big and it also have non-numerical data, the prediction becomes difficult, and we have to make number of adjustments to get the correct outcome. Furthermore, these fitting models will not anticipate the output of supervised learning models. However, moreover, for all variables, the weighted arithmetic mean requires complete data. It may be impossible to compute the weight correctly if there is lacking data. Here is the references, and thank you.